Hey. Got lots of stuff going on.
Hey, Jason.
Hey, how are you?
Good.
Is this the pregame? We're not in the middle of the meetup, are we?
Can I grant you presenter?
Oh, presenter. I was telling my girlfriend I'm helping with the meetup, and she's like, "When is it?" And I'm like, "Right now." And she's like, "Are you going?" And I'm like, I'm presenting via the internet, love."
Yeah, I'm trying to figure out how for us to share. Oh, screen share. Okay, let's see, screen share.
Do you want me to try to?
Can you see the screen share button?
Yeah, I'll click it. Wait, here. Share.
Okay, good. So we both have screen share ability. That's all I need
Cool.
to confirm before we get too far in.
Cool. Close that. Close that.
Okay, so we're gonna try to mirror. Weird. And then we're going to go new. We're going to screen share the whole screen. Sure. Okay, so we're going to try to do this one.
What's happening?
Okay.
What? Come on, man.
Hey, can I try that?
Yeah.
Oh, way better.
Okay. In a little bit, you're gonna have to leave me alone, though.
It's way better, but it's still not that great.
I'm on the phone, just so you know, Mary.
Okay.
Okay.
Okay, Jason.
All right. So you get me dressed like that.
Oh, you're on the video?
Yes.
I don't know how.
I'm doing stuff.
Fine.
All right, here. Let me put it differently. Leave me alone.
Okay.
All right, get out of here. Holy cow, man. There we go.
Okay, Jason, can you confirm that you can see the presentation screen and that you can still hear me?
I can still hear you and I can see this screen, but I think I'm sharing, so I should be sharing what you're sharing or something. I see that. Yeah. So, yep.
We'll get to yours second, because remember we're doing C and then Rust.
Okay, I'm gonna stop sharing.
Okay, yeah. New deal, Capital Factory says I must shill for them because they gave us the space. Here I am shilling for them. They want you to sign up for some stuff. Their conversion rates, make sure they keep giving us space. On the show. Okay, so today we are covering safe NIFs in C, C++, and Rust. I'm going to be doing C and a little bit of explainer of C++. There's not much of a difference. And then Jason, who is calling in remotely, will explain it from Rust. Okay, I run the meetup. here every month. Yeah, I am Luke. Around the room.
My name's Tom. Ben. Andrew. Keith.
Anyone used NIFs before?
Yes.
Okay, yeah. Probably everyone that's done any sort of thing with a sign-ins probably had to use the decrypt one. So we probably all used it. Okay, NIFs are one of the options for Erlang interoperability. The default one, which you don't really think about as interop, is distributed Erlang. It can work as a cross-language interop because you can both do C nodes and Java nodes. For Java, there's the thing called JInterface. Like weirdly, EPMD can actually detect that as a C node because like it understands that you can't do certain monitors and certain links to the node as a whole because of the way C nodes work. After that, you have ports, port drivers, and NIFs, which is why we're here. So like I said, distributed Erlang is mostly for C and Java. Like I use JInterface to do the IX shell and the debugger in IntelliJ Elixir, which I write if anyone's not aware of. Ports were like the original mechanism, like they were the thing that the original Erlang team put in there to talk to the hardware in their phone switches. Those were ports. So ports will open up an external program in the OS, and then it just talks over bytes of streams. In like a Linux or Mac, it's kind of the equivalent of just piping to stuff in a shell. It wouldn't launch in a shell by default though. The important part about this is it's in a separate OS. It's in a separate beam process. But unlike distributed Erlang, you can't do it on another. You can't do it on another machine. So if you can crash the machine, it can screw up your life. Port drivers are the same OS process, but a separate beam process. So it still looks like you're talking to a port. You're still sending messages to it like a port, but you're actually loading it into the beam. Like this seems like a way to make a port faster, but I'm not really sure why it's necessarily better because it can still crash everything. One of the port drivers that does exist is the TTY that we use for IX, you know, the thing that lets you do tab completion, lets you do things where you're not entering a whole string and hitting enter before it responds. That is a port driver. And it actually is a separate executable. Like you can test it out by writing it as a separate like executable if you're not sure how it works. I guess that's one of the reasons why it's useful, but something like yeah. Goon. No, so it's still just a port. It's not a port driver. It's just a way to wrap ports because so I didn't do it because we're not covering ports, but there's two levels of ports. There's like pure byte stream, you agree on the protocol. And then there's something called Erl interface where you will talk Erlang term to binary format over the port. And so that's more like what Goon is doing, is Goon is allowing you to take a thing that has no idea it's going to be wrapped into a port and have it talk Erl interface because it's nicer. And Goon also does a thing because by default, ports don't understand signals. I think they added a little bit in OTP 20 or 21. And so you couldn't do the Unix kill signal. Instead, the only way to kill a port was it was supposed to just know that when you close the pipe, that it was supposed to go away, and alas, it didn't. And Goon like kind of papers over that problem. So using the NIFs, we get it's different than everything else because we get function calls. And so it's the fastest. And so why do we always use NIFs? Well, it's the same reason why we're not all writing C and we're instead of writing Elixir and Erlang, because we probably try to write C and bad things happened. Or it's just really nerve-wracking to not screw it up. Every time the unsafe code is running in a different location, a fault in that code is recoverable. So distributed Erlang, if you're running on a different machine, it can go down and you could just tell AWS or Kubernetes to restart it. You start using a port, it's on the same machine, you have to be worried that if it has runaway memory usage, unless you have your ulimit set up correctly, or if it is running a disk, it could kill your Beam process without actually affecting the process because it just exhausts some resource that the OS shares between OS processes. Getting to port drivers, you're already loaded in. The only caveat is maybe with the right error handling, you could not have your Beam process that's talking to the port driver port die because it could do rescues. But it would still have to be that the port driver didn't do memory corruption or a seg fault or something. And finally, NIFs are super dangerous all the ways. So let's try to make the least safe thing safer. So since I didn't spell it before, NIFs stand for native implemented functions, which is just saying native as in it's going to be machine code and compile down to native machine operations instead of being bytecode. No matter which native language you use, the Elixir module is always going with the same. Any functions implemented by the NIF will have stubs. By default, there's a thing called NIF error. The reason why NIF error is helpful is because it does this trick with dialyzer where instead of looking like a call to Erlang error where it'll be like, oh, you must annotate this function as no return. I'm going to always think it doesn't return, and it's always going to raise exceptions. It's going to screw up all your dialyzer runs. Even though it's documented as no return type here, it will actually act like it returns term. And so dialyzer will be hunky-dory with analyzing your Beam code and not being able to analyze the actual native NIF module that gets loaded on top of it. You don't have to call NIF error. You could do a stub that actually returns values when it's not there, or you could take that thing of if I can't load the shared library because I couldn't figure out how to target ARM because I used some assembly instruction that only x86 has, you could implement it the slow way in Elixir or Erlang and have it on top, and that will work. It's just not very common. It's usually there's an entire Elixir library and then there's the C replacement for it. There's not one where it magically meshes over the top and if it doesn't load, it still works. I haven't seen anyone do that. If someone knows of it, please point out. So how do we actually load? Right now, this is a normal Elixir function. It's not magic. It doesn't, oh, there's a shared library of the same name. I'm going to magically load the NIF. Nope, that has to be explicit. So there is a module attribute called onLoad that you can do in any module. This is sort of like the, in DLLs and Windows, there's not a main, but there's an entry point. So when the DLL loads, you can do some setup stuff. Well, all Beam modules can also do this. And for NIFs, you just define a function that's going to actually do the loading in the NIF. The reason why we wrap it, this actually comes from bcrypt, is that the error message is not terribly helpful if this fails. It'll just be could not load module, and then this error stack trace from the code loader. It's not going to explain anything. So what I would recommend, because it's a good example from bcrypt, is you actually raise with a more human readable error. In bcrypt's example, it actually points out maybe you're not using a new enough OTP. Maybe you forgot to do your compiler, because this could happen is if it can't compile, sometimes the makefile won't error in a way that will actually kill your mix compile, and so it might try to load the NIF without it ever actually being compiled. Like I said, it's just there. I don't know if you can call it with arguments. I'm not sure why you would call it with an arity other than 0, but you have to call it with a name and an arity. That's the human readable version. And then to actually load the NIF, we're going to use code privdir, that'll give us our /priv, and that will actually be in the right spot whether we're in dev or build or release mode. We're going to make sure you use file name join the Erlang version and not the Elixir version, because Erlang load NIF, being an Erlang function, expects careless paths. In Elixir, we call them careless. Erlang will, of course, call them strings. And so we're using all the Erlang functions that we get careless paths for everything. We don't have to convert backwards and forwards. The equivalent in Elixir would be path join if we were doing this on Elixir string paths instead of Erlang string paths. The 0 pass to load NIF is just if you want to pass extra information to the shared library's entry point. An example of something you could do is you could set the version attribute explicitly, which is something that is generated by the compiler to be the MD5 sum of your AST. But if you set it to a version, you can use that to be like, when you're doing code upgrading, you can be like, oh, I'm going from 1 to 2, and my C library knows how to convert its internal data structures, in addition to the Elixir data structures when you do that. It'd be really nice if you did that, because like most of the C extensions just completely crash any of the tools that try to interpret the code for the debugging. So like the debugger that ships with OTP, or the debugger IntelliJ Elixir, if you try to load bcrypt because it's not set up to reload the module, it just crashes out. Make this slightly more useful, we're going to give a struct that the NIFler finds so it can find some treasure. This is just to show how to make structs inside the C code. So that we can prove the different versions in C and C++ and Rust behave the same, we'll set up a test. This test may seem kind of simple, but we're checking a couple things. We're checking that we can create atoms, that we can create tuples, that we can properly fake structs, that using the enif map functions, and that we can convert null terminate C strings to Elixir strings, which is possible to screw up, because I did that. C is both the native language of the Beam and the lingua franca of foreign function interfaces. So the most direct way to write a NIF is in C, and C++ is about the same because you can write C and C++. There's not going to be a big difference there. Even Rust is calling into the C bindings. There's not like some more direct way than the C bindings that OTP gave us to do this stuff. So to do an if, you just include urlnif.h. If anyone's curious about how to get the path to urlnif.h, there's a line in bcrypt that does, and I can show the make file. I didn't include it in the slides here just because it's a very long file, but we can get to it at the end if we have time. You define your NIFs, and you call a macro called urlnif init that does a bunch of setup, like a bunch. So it's actually kind of defining the entry point to your shared library by doing that. You're just saying, here's the functions, here's the arrays. Looks really simple. It's actually doing a bunch of stuff, prologues, epilogue, all this stuff to make sure that your shared library actually behaves like a NIF module should. So for anyone that hasn't written C, like in Elixir, you have to use headers to include the signatures for everything you're going to call. You can't just call the function directly and have it just work. We also need to define our return types and input types at a time with prototypes, or it's going to behave weirdly. Static is the equivalent of private for basic C, so that it doesn't get exposed. It isn't allowed to be linked outside of the .o you're making. You'll notice that all these functions take an urlnif m star, which is a pointer to the environment from the Beam. The reason for this is that all those urlnif terms, they're not pointers to memory. The actual encoding for pieces of data that can be like garbage collected by the Beam are usually unsigned longs on like 64-bit. And a lot of times, they're just numbers with a couple of the low bits set. So it's not a tagged pointer. Sometimes it's just a tagged value. And so it's not a pointer to the data. It sometimes might be literally the data. Like it might literally be a tag of it's an atom with the index into the atom table, but not a pointer into the atom table. Just like, think of it more like a handle than an actual pointer to the real data. And that urlnif env is needed there because it's needed to translate from that tagged value to the real data when you're doing more complex calls. The only NIF we want callable from the Beam code is burrow. And we register the callable NIFs using urlnif func structs. Urlnif funcs contain a name, array, and a function pointer. You'll notice that the NIF itself, C array, doesn't match the Elixir array at all. So here, burrow is going to have an array of 0, but the function pointer is always the same. The C function is structured similarly to like main in the C program. So you have the number of arguments in argc, and then an array of all the arguments in argp. This also means, though, that you can have one C function that is multiple arrays in Elixir or Erlang. To make atoms, you call NIF make atom. It automatically handles determining whether the atom is pre-existing or a new entry needs to be made in the atom table. There is, though, the safe version, enif make existing atom, where it won't create a new atom in the atom table. So if you're bringing in user data and you want to be extra safe, you could use that version. The one thing is, unlike your actual beam modules, where these atoms that are used will point to the constant pool version, so like kind of read-only memory, since this is being made in the environment, if your C code is the first thing to get run, that OK will have to get created in memory. It won't use the constant pool. So it has slightly different memory dynamics than if you were doing the equivalent of like hard coding :OK inside of an Elixir module, where it would go to the constant pool for the constant literal chunk in the actual code. No, because it still does a lookup in the atom table, but it's slower. Because when it's part of the literal, it actually, the actual beam bytecode instruction, like the argument value is go get it from the literal table. And so it's more efficient that way. And a lot of the stuff that made structs more efficient in like OTP 20 and 21 from the Elixir team was having the code for maps realize that, oh, this atom is the same and it's in the constant pool, so I don't have to like reinitialize the whole thing, and it made maps more compact. And so I'm not sure when doing this if that same compactness happens through the C API. To make a tuple, you use enif make tuple, but that one, if I didn't have the 2 there, it'd be variadic, which means it can take a variable number of arguments. But also in C, except for like weird special handling that printf has now to be like, oh, you did %u for unsigned, but you put in a signed value, that's illegal. Most variadic functions can't check the types. It's just like at runtime they'll be like, oh, you fucked up, you gave the wrong number. So the docs for the NIFs say use the version that is the specific number of elements you want in the tuple if you know it, because then it'll get checked by the compiler, which I happen to agree with. Likewise, there's the same thing with lists, where if you know the exact size of the list, there's lists 1 through 9, I think, so that if you have a small list, you can make them directly. To make this example simple, we're doing a 1-element list that includes the found treasure. And I'm going to hard code the values of the name and the value. Because it's very hard to actually get a good random library in C without an extra dependency. Like, you're never supposed to use rand and srand anymore. And so it'd either be hard coding devu random in Linux, or like including libsodium as a dependency, and it's just not worth it for this demo code. If you're like, oh, I could call the Erlang code to get their random. Yeah, you can't. NIFs cannot call back into Erlang code. You can pass like functions from Erlang, but like, I'm just going to call a module, an Erlang module, and it'll just work. No, that is just not a thing that you do in NIFs. You cannot call back into Erlang code. It's weird. Which is why you get garbage like this. So that Niffler treasure struct, in Elixir code, we would just do %, the name of the thing, and it would automatically do the compiler. Or doing it the long way, you do Niffler treasure dot $struct, closing parentheses, and we give you that struct back. We can't call that code. So we have to know the internal representation of structs and make it by hand. You know, it's not like you can screw this up and add like 3 underscores in struct like I did or anything like that. Which again is why the test spells out that the short form of struct matches to check your work, that you can actually make what looks like normal Elixir stuff. So there is a helper to make a map from an array of keys and array of values. So we need to compose the keys first, and then compose the values. This being C, however, there's no check that the keys and values and the passed size match. Those being literal arrays, you could do a thing in C where you ask for the size of keys overall and the size of the first element. and it would get the size correctly, but there's no compile time assert in C by default. So there's no way to check that this 3 matches for keys and values. The other thing to remember is when you're doing the struct, the name of the struct is an alias, and the reason they're called aliases is because they're aliases to the long form, which is actually an atom. So you always have to remember to do Elixir dot in front of all your Elixir alias names when you're making them into atoms. Since all the enif functions from OTP, they don't really acknowledge that binary strings are a thing. And so there are enif functions to make strings. They mean careless. And so I had to write something to just make Elixir strings. So just pass in a normal C string, which is a constant character pointer. Take the string length. C strings are null terminated, so you're always going to have to count the size of the string. You can't just know its size. It's not stored for its size the way actual binaries are. The weird part about this that tripped me up is that usually when you're asking for the number of bytes in something, and if you have a string and you're like, how much memory do I have to allocate to make it fit? You would go, oh, it's the string length, which doesn't include the null byte plus 1. I did that, and I just got a binary with the correct byte sequence and then the null character in it. So make new binary says it takes a number of bytes, but it doesn't count the null byte, probably because binaries don't contain the null byte, so it's okay, but it's a weird thing to get used to if you're used to doing C. And then you still have to make new binary. Like there's no enif binary thing that's just like, give me a C string and I'll shove it in. So the cheapest way is this enif make new binary. But it has a weird calling convention where the actual data, you have the string copy in, and it's the output value. But then the actual term you return is a pointer you passed in. Weird structure. Right now our NIF works and it's safe, but that's because it's very simple. This is unrealistic, and it doesn't actually cover Joel's original request that what do I do, how do I do timeouts? Because that's realistic. We want something where we want to say a timeout and we want to behave nicely. And so we need something that takes time to do that. So let's just make this really slow. So here, we're going to sleep for 60 seconds. And it does that great. But the problem with this is, since this is C code, this isn't preemptible. So the beam is preempting, but only at the level of byte code. Its C code is still non-yielding. It's only cooperatively preemptible. It's cooperative multitasking. It's not preemptive multitasking the way the Elixir code would be. So this just blocks that. So if I did enough of these calls to do all the scheduler threads on the beam, it would just lock up. So that means we have to do a cooperative timeout. So we're going to pass the timeout. We're going to track our elapsed time. And we're going to yield with a callback called enif schedule nif, where when we use up our time slice, we'll then say, call us again with these arguments, and we'll continue our work later. The time slice, by the way, is 1 millisecond. But it's early in doc, so it's like, this has been beta. It's been beta for 15 years, and it's not always 1 millisecond, but try to code against the standard. I don't know if there's a way to get what it really is, but I targeted 1 millisecond because that's what the docs said it kind of sort of was. So we're going to summarize the new design with some new tests. First, if the NIF takes longer than our timeout to find treasure, it should return error timeout. I was going to have raise a timeout like a gen server call, but then I have to look up what that actually looks like, and it's kind of complicated, so I'm like, we'll do it this way. Don't worry, we'll still have exceptions where people pass in bad values. If the NIF is given enough time to find treasure, it finds it. And this is also going to test that we can have infinity as a timeout, because the timeout type in OTP can either be infinity or a number in milliseconds. And we want as much time, we want as much research as possible, so we're going to say that if the elapsed time and the timeout are tied, we're going to let the elapsed time win. From the test, you may have noticed that burrow is no longer 0, arity is now 0, 1, or 2, so we're going to use default arguments. I'm not 100% sure why this works, but when you load the NIF, all the other arities still exist, even though the NIF only contains the 2. So I think the NIF only replaces the functions that exactly match the arity, but this happened to just work. So don't question it. And the reason why I went with this form is because I tried to do burrow, 0 burrow, burrow 1 burrow, burrow 2 burrow, and it just segfaulted. So that was not the right way to do it. So I went with this way, and it works. Yeah. Yeah. So if you want to see an example of a different way of doing this, there's a good demonstration of the time slicing in a library that's made just like this to demonstrate NIFs called bitwise, where instead of calling the user-facing function, when it resumes, he calls one called XOR2 that is only there to be called for resuming in the background, so the user can call directly. That's another option you can do. But doing it this way, I had the option of I can pass the elapsed time to test it, so it's kind of nice for that. We need to get the optional arguments out, so we're going to have to test for some stuff. Find treasure also returns directly instead of being wrapped with an OK tuple because it could fail with an error tuple or an exception, or it could schedule another NIF call. The reason why I end up going with structs here is I originally went with URL NIF terms, but then I would get the timeout out like I would do in Elixir code, but then immediately have to check it with the enif functions again and be like, well, is this infinity? Or is this an actual integer? And I'd have to suck the integer out of the URL NIF term, and doing that over and over again seemed kind of inefficient and kind of verbose. So instead I made a struct where it has the C version of the value and the URL NIF term version of the value, so I can pass the original timeout along when I want to, but just check if it's infinity or check if it's a millisecond quickly just by checking the type. So this is just a tagged union. So it's a struct with the type and then a union for the values. That's what I ended up doing to make it slightly easier on myself. Find treasure can no longer wrap the output. Find treasures can no longer wrap the output of find treasure in the list because it could error too. So we start to get lovely error handling in C. It could call enif schedule NIF, in which case the value needs to pass through. This check for schedule is first because the return type from enif schedule NIF will cause some enif functions like enif is tuple and enif get tuple to segfault. This is not documented. It was not fun to debug. So, to summarize, enif schedule NIF returns an opaque type, but it's just documented as an URL NIF term, and it just says you must return it. It does not tell you it is not safe to look at. Do not look at it or it'll explode. Weirdly, enif is exception is safe, but the tuple ones are not. I kind of think it might be a bug, and the reason for this is that it is unsigned log 0, but like I said, it isn't 0 like it means null. This is 0 is actually defined as the non-value in the actual code, but it's not in URL-nif.h. It's in URL-term.h where you have to find this out. Also, this value can differ whether you're in hype 64-bit or 32-bit. So hardcoding as 0 is not technically safe, but otherwise stuff will blow up. There's no function to check that it is the non-null value in the enif functions I could find. The bitwise example, they just return the enif schedule NIF directly, so they don't have to worry about detecting if it's different. The other way, of course, around this would be to make a struct that is the struct that contains a type tag, like I did with the timeouts, to be like, oh, this is returning a schedule. Please don't look at the actual term value, just return it. And that would mean I wouldn't have to hard code the 0. I did do that, but it was slightly more verbose code. Once I figured out it was 0, I'm like, I'm okay hard coding 0. But still, watch out, it'll segfault. It won't make any sense. If the NIF isn't being rescheduled by find treasure, then find treasures takes the treasure, repackages into a list. In a more realistic example that allowed a variable number of treasures, this would have happened in a loop, but we would have needed to keep track of an accumulator list, and it would be complicated. I didn't want any more code than necessary. I am saving some time though since I know that when the checks pass for is okay, I know the first tuple element is the okay atom. I'm just going to reuse that directly instead of making a new atom, because even though the atom exists in the atom table, it's supposed to run the C code to find it in the atom table. And so since I already know it's there, I can just reuse it, because like I said, the atom is just a tagged unsigned log with the index into the atom table. So I know it's safe to reuse it, and I'm not like, it's not like it won't be freed or whatever. Like you don't really, since all these are unsigned log, you don't really have to worry about any of those. You don't have to worry about freeing the value. Finally, if it's an error tuple or an exception, I just let it pass through. Find treasure now is responsible for slicing up the work. So I'm going to do some work. Work is a callback. I'm going to measure how much time it takes, add that to the total time, figure out how much the time slice I ate, and consume that time. enif consume time slice serves 2 purposes. One, it tells the beam how many reductions that your C code should eat. So you don't say how many reductions to eat, mostly because, but you do say what % of a time slice your code used up. And then also it'll return true if you've used up your whole time slice. So the bitwise library I was talking about has a very cool thing where when it reschedules, it tries to figure out, like, it can do this many C operations based on how long this took. So like when it's over 100%, it'll be like, oh, I'll do the less work next time to try to keep responsiveness tuned to how much work it's doing, which is very cool. Measure elapsed milliseconds acts like timer TC from OTP. So we're going to measure how long the function work takes. All these functions get time of day, and timer sub are all from systime.h. I didn't actually know about timer sub. I don't know if it was added to POSIX more recently since I was in college in the early 2000s, but I don't remember it. But it makes the math way easier, so use it. Get time of day is weirdly just the seconds and the microseconds. It's a weird structure. The name doesn't make any sense. Just know it's the thing you use to measure time. I picked a fixed time for how long it takes Elixir to find a treasure, only because I didn't want to include randomization, like I said. So I'm just going to say that if it searches for 5 seconds, it finds stuff. I make sure to check the timeout before rescheduling the NIF, as otherwise the timeout is never checked. And I actually had the order flipped, and it just would always find treasure, but after like 10 seconds. So very important where you do it. The reason why this one is first is because I said I wanted the elapsed time timeout ties to go to elapsed time. But you could flip it and have this one first if you want the timeouts to win. Finally, if the timeout slice is exhausted, I'm just going to reschedule. enif schedule NIF is weird in that you have a return value, but you shouldn't look at it, but you got to return it. Some notes on the ergonomics of the code. The OTP docs say use enif, make bad args, and I don't know if anyone's passed a bad argument to the ats functions. We're just like bad argument or argument error, and you're like, that was helpful. Yeah, that's what this thing does. This does those super helpful error messages. So don't do that. Instead, you can make a good argument error. But just like having to know the internals of structs for the treasure, you have to know the exceptions. Def exception in Elixir is actually internally calling def struct. It's a struct that has the normal struct key, so you have to understand that about structs. But you also have to know, by looking at the code for def struct, that exceptions have this double underscore exception key that is set to true to signal I am an exception. Thankfully, Elixir argument isn't that complicated. It just has a message key, so we can just use the make string I already made to set the argument, and it gives us a nice argument error. I don't show in the test, but I accidentally passed bad code to it, and I got the thing, so I proved it worked. Yeah, the struct key just like structs, true exception, set the message. For C++, there is no wrapper library that I could find. The problem is that Earl NIF end is passed into you, so like you can't use destructors. There are cases where if you can actually ask to have a thread started. So I didn't show that because we wanted to target timeouts and not dirty threads or dirty schedulers and such. But through the driver interface, which normal NIFs have access to, you can ask for have a new thread started. And in that thread, you can ask for a new env to get made. That you could wrap in a C++ class so that it had destructors so it got cleaned up correctly. But there's not much really different with C++. You could use standard features with those threads. But the weird part is you probably don't want to use new, which a lot of C++ you don't use new anymore. But you would want to do that because there's actually an enif alloc so that you allocate in the beams allocation pools and not just your own malloc. So almost anything you can think of, you have to go through this enif function. So it's very hard to make a C++ wrapper that makes sense, where you can actually take advantage of RAII and like have destructors just work. It's unfortunate that it can't have a cleaner wrapping, but it doesn't. And with that, we will move on to Jason with the Rust stuff.
Hi, how's it going?
Hey.
Hello. My name's Jason. I work with Luke at Dockyard. I'm going to tell you guys today about a framework for writing NIFs in Rust that alleviates a lot of problems that Luke mentioned. In fact, more than I had actually realized until his presentation. So I think what I'm going to do is I'm going to share my screen and let you guys follow along if that's okay.
Yep.
Cool. Give me just a second. See what I can do here. And you should see my screen. Looks good.
Okay.
Great.
Let's
Is this okay, or is this like horrible?
No. I had my camera pointed at the screen, so it went weird.
Yeah,
okay.
yeah,
We're okay now.
yeah. I noticed. Believe me, I'm like, cool. I'm seeing myself. This is great. Nothing I like more. So
Yeah. Can you make it bigger?
Yeah, absolutely. Bigger font.
Ooh,
And
yeah.
let's do this.
One sec. We're gonna try to.
It's one of those things that's helpful, but it's really hard to see.
Oh, I can't. It's gone weird.
We broke it.
Anyone know how to make it big? I agree.
You guys still with me? I can't.
Yeah. We're just trying to figure out how we can make your video full screen.
Oh, okay.
Like some that.
You guys see this one?
Yeah, it's just very small. It doesn't want to allow us to make you full screen for some reason.
Well, that's nice. So Luke, do you want to drop?
Remember how you did it when I presented, or was that different?
I do not remember. That was I'm not sure if we used Hangouts for that or what.
Okay.
Oh, you can drive, so I could just talk you through it if that's cool. All I need, everything I need is inside of this repo. So if we want to do it just so you can drive and I'll just talk about stuff, it'd be fine.
Okay, sure.
Okay.
Let's try that.
Yeah.
Yeah, they both are.
And
Mine's just called Elixir. It's under my account. And this is.
Luke, can you make it so that I can see this screen again? The screen share?
Oh, yeah.
Thanks. Cool. All right. So yeah, so I've been using Rust to make NIFs for probably 8 months. I have written a few NIFs in C, and I had similar experiences to what Luke had talked about, having seg faults and memory issues. And so I assume Luke is good at writing C. Elbow Jason is not good at writing C, so we had memory leaks and weird stuff going on. And needless to say, it would crash me out of the VM, right? So if you scroll down, Luke, in the README here, I wrote some to-dos, and I got those to-dos done, and we're going to look at some actual code to write Rust NIFs, to write the NIFs in Rust. So let me talk about what Rust is real quick, and then we'll move on. So Rust is statically typed, type safe, memory safe, data erase free systems programming language, right? So that's a lot of jargon, right? But what it basically means is you get a lot of guarantees about the memory safety and the behavior of your program with regards to safety. And I know that doesn't mean much, but there are things you can do to a computer to make it blow up, right? And I don't mean physically blow up, but I mean shut down, run out of memory, leak memory, cause an exception in your OS. There's all sorts of things that can go wrong when you have data races or memory unsafety, or a million other things can go wrong. It's developed by Mozilla, and it's got a really extremely friendly open source community. So if you go in there, you ask questions, you don't get told to shut up or go away or anything. Why I use it? I use it because I'm really bad at C, and because it comes with a neat framework for Elixir called Rustler. And what Rustler lets us do is Luke had a bunch of stuff he had to do to get his project ready to run. And in a similar way, we have some of those things in Rustler, but they're for the same reason that any framework is used, it's streamlined, right? It makes it a little bit easier. Yeah, so why Rust for Elixir? The reason I choose Rust for Elixir is if I am doing something in Elixir and I don't think it's going to be fast enough, like mutating matrices, right? Doing matrix math. Elixir is not going to be good at that, no matter what you do, right? We have immutable data structures, we have linked lists, we don't have arrays, we don't have matrices, we don't have vectors, right? We can't mutate memory. And so if you want to do something like that, you turn to a NIF. And if you want to do something like that without crashing out of the VM, I use Rust, right? So I can't tell you, I've been using this for 8 months, and I haven't used it every single day, but I don't know, twice a week, I hacked on some Rust code, and I have yet to crash out of the VM, which is a big deal, right? Luke, did you crash the VM at all when you were doing your thing?
I crashed a couple times.
Right. So
yeah.
So he crashed a couple times, and how long did you spend developing? time-wise?
I mean, once the crashes occurred, it took a couple hours to figure out why it was happening.
Right.
Because I went down the thing of like, maybe the debugger will help me, and like, nope.
No, nope, not on this one.
It's like, wow,
yes.
a stack frame that goes from the beam to the OS kernel. Yeah, I get the OS kernel told me it was a site fault. That was helpful.
So the worst thing you can, not the worst thing you can get. I'm sure I'm like this. I make this caveat. The worst thing that I've seen using Rust code is a panic, which leads to loss of the Erlang process, right? So an exception, right? An exception crashes the process, and you can deal with that with a supervision tree. So why not Rust? Let's go down one. If you're really good at C or C++, you might not need it. I know there are people that write NIFs. Frank Hunleth writes tons of NIFs that are safe, right? But he's also been doing C for 25 years. So, yeah, right? Like, I don't have 25 years to get it right. If you don't need thread safety, if for some reason you know that you're never going to share if you know for some reason that you're never going to share your NIF resource with another Erlang process, you can write it in C and you'd be just fine. And if you need a quick prototype, you might not pick up Rust. Rust took me a long time to learn. That might have been a developer thing. Like, I might not have been ready for what it means to write in a systems programming language, but it took me a while to learn Rust. So scroll down, please. I'll say it, Rust is not an easy language. Like, as much as people would say, oh, it's easy, it's not. Excuse me. It's not easy in that there are things that exist in Rust that do not exist in other languages, as far as I know, right? And by that I mean there are 3 types of strings in Rust, right? There are what are called static strings. There are string slices, and then there are strings that are allocated on the heap, right? And I realized, like, yeah, those all exist in other languages, but in Rust, I just wasn't ready for it. Let's put it like that. So not an easy language to learn. But you can do what's called leaning on the compiler, where you write a program, you try to compile it, it'll give you an error message, and then you just continue to churn through these error messages till your program compiles, and hopefully you have a working program at the end. So we're going to go through a few things. We're going to see how it works from how to set up a NIF from the Erlang side, how to set up a NIF from the Rust side, and so Luke has already talked about Erlang NIF error. It's pretty magical. I made the mistake of raising once without the Erlang NIF error. That was a nightmare. So yeah, lesson learned. So Rust has, scroll down a little bit, sorry. Rust has an idea of a thing called ownership. I don't really want to get into ownership right now. If you want to learn more about it, it's the key thing that makes Rust different from C or C++, right? I'm going to explain some parts of syntax, right? And when it says read this, what I read that is end with a lifetime of A, right? NIF result with a generic term with a lifetime of A, right? Okay. And how NIFs work from the native side. So we're going to get into everything else in this README. If you would, Luke, please go back up to the top and click on the simple NIF example project. So this is a mixed project, excuse me. This is an Elixir project that I started today. And it looks like a normal project, right? So if you go through the README, you'll see the steps to set this project up. So let's actually do that first, and then we'll get into the source code. So to create this, all I did was I made a mix new, right? Started a new project. I searched for Rustler on HexPM. There's a link to the search for Rustler. I added 0.18.0 to my mix.exs. I left something out, actually, and I totally forgot about this till just now, but you have to have Rust installed. It's very simple. You can go do that, figure out how to do that on your own. It's it's simpler to, in my opinion, it is as simple as installing Elixir or Erlang or any other programming languages. There are no caveats about paths. There's no caveats about paths that like Golang or anything like that. So you can install it very easily.
Well, there's a caveat that you may install it once with Homebrew, but after that you probably want to use Rust Up.
Oh yeah. I install with Rust Up. I only install with Rust Up because Rust Up lets me control my versioning a lot better than Brew. Right? Brew is sort of take what's available, and then Rust Up is more configurable if you need it to be.
Mm-hmm.
So I install my deps. I run mix rustler.new, and I get a prompt, right? So it leads you into a prompt, and the prompt asks you for your module name, and then you enter your module name as if it would appear in Elixir without the Elixir dot prefix, right? So on 5A, simple rust nif.native is the module name that would come after def module. This is where we want it to look, right? And then you hit enter, and it says for the library name, what do you want to name it? And it gives you this default value in the parens there, and I just hit enter, right? So the note below this says there should be a folder now, native, that is next to your Elixir lib in the lib folder, and the native is where the Rust source code quote lives, right? Lives. So to get this up and running, you can. So I put this file in the wrong place, and then I was like, it's too late to change it because I did this like an hour and a half ago. So I put it in libnative.ex. It may have supposed to be in lib simple rustnif native ex, but you know, whatever, refactor. So the really important parts here are idef module, that's simple rustnif.native, right? The module name is important here, right? The use Rustler OTP app must point at the OTP app that is in your mix exs file, right? And then this crate over here, this crate argument must match what is in the native source code, right? Yeah, exactly, those things, right? The last important thing is you have to have any functions that you want to call from Rust have to be in here the same way that Luke showed before, right? So this was all generated for you and printed out, similar to like a Phoenix project where it says like add this, you know, when you generate a route in Phoenix, right? Generate JSON, you would get a little command line prompt that says add this, right? And similarly, when you run rustler.new, it'll say in the printout on the command line like add this to this file, right? So you follow that, and then the next step, please. In your mix exs project 0 function, you're going to add a compiler for Rustler, right? And you're also going to add a keyword argument for Rustler crates that calls a Rustler crates function. And then the Rustler crates function is going to call, you're going to lay that out as this code. And once again, that path points to the folder that was created, right? And you were going to want a mode in there, right? And then simple rustnif, I'm not positive that the simple rustnif keyword there, the atom in that list, needs to be the same as the OTP app. It might need to be. I've never tried to change it because it's not something I was interested in. I wasn't trying to hack around that part of the code base.
Jason.
Yeah.
Let's see something. Yeah. So for C, there's also a compiler. I just didn't show it. There's a compiler called Elixir make that calls the make file to compile C. So I'm also using an extra compiler when I'm doing the CNIFs. It doesn't just work out of the box.
Right. Cool. So what this does, guys, what he's talking about is when you add that in, and you add in the Rustler crates argument, what happens is when you change your Rust code and you type recompile in IEX, it will compile. It will see the changed files in Rust code and build it and make it available in the Elixir runtime in IEX. So this is a way, using this, it lets it know that when you compile this project, you must also use Rustler, and then Rustler creates, lets Rustler know what configuration, like where it should look for stuff, right? So if you got to this point and you ran IEX-s mix, you would be able to use the add function, right? So let's go over and let's look at the source code now. So if we go into, yep, right there, and you go into lib, if you go into lib and you look at the native file, it will be exactly what's in, and then you can just look at this and then back out. It's exactly what's in the README, right? So we didn't, there's nothing special here. Sorry, Luke, I shouldn't even let you do that. I shouldn't have had you do that. That was dumb. So if you go into native, right, you'll see this is the equivalent of a brand new Rust project, as if you had run Cargo, which is like Rust's version of Mix, right? In there, it comes with its own README. It comes with its own dependency thing called dependency and or configuration for the project called TOML, a lock file for its dependencies, and then source, right? So if you clicked on source and librs, it gets one file, it's lib, right? There's a bunch of stuff going on here, and I'll explain all of it real quick. So I don't really remember what macro use does. I believe it says that that you're going to try to use a macro out of these crates, and that it should be loaded before it attempts to compile.
I think macro use is like, I'm only using this for macros. Please don't make this a dependency.
Oh, okay, right, maybe. I don't know. It's been a long time since I've looked at what macro use does, but so on 5 we're using Rustler, and we're bringing in a few things so we can use them without prefixing Rustler. On 7 we're defining a module called atoms, and then we have this thing called Rustler atoms bang, and what that is a macro that is allowing us to define, it's sort of allowing us to define DSL. So this is a domain specific language where we're saying we've got an atom that's going to be called OK. And then after that, the atom OK is available as a function call from the module atoms on 7, right? So if you'll see it later in code, I'll point it out. On 16, we have basically this is like a macro that links the NIF. This is the macro that links the functions of Rust to Elixir, right? Luke had something extremely similar to this, right? Like so much so that I was kind of like, I didn't know it would look quite that close, right? Because it's been a long time. So we define what the module is that we're looking for on the Elixir side. We define the functions and arities that we're going to be pointing to and from. And then on 19, we have this thing called onload, some onload, and that shouldn't actually be there. That should be the word none. So this project is actually broken. I made a change and I screwed it up. That should be the word none, as in N-O-N-E, capital N-O-N-E, but I'll come back and fix it. And you'll see why in a minute. If you tried to run this project right now, it would say there's no onload, I'm pretty sure. I got the projects messed up, I guess, while I was editing. But anyway, there's our add to function down here. And so what we're doing here is we're trying to get num1 and num2 out of the args vector, excuse me, the args slice. And if we're able to do that, we return this. Yeah, sorry. So I'm going to read all of this out loud in just a second so you guys can kind of understand what's going on. But on 26, it says OK, right, which is to say that this is telling this is telling Rustler that what we tried to do was OK. And then there's a paren right after the K in OK, right? And that is saying what we're about to return, right? So we're about to return something, and that something is actually a tuple, right? That next paren starts a tuple and then ends a tuple all the way over there. So what we're returning is OK num1 plus num2, and we're encoding it into the end, right? So on the other side, on in Elixir land, when this comes out, this is actually OK and the sum of the two numbers that you passed in, right? So unlike Luke's encode, and unlike Luke's tuple2 function, you just give it a tuple and it figures out that, sorry, Rust has a thing called a tuple, right? Hilariously, it's used almost the exact same way we use tuples in Elixir, where it's just like two values. They might be the same type. They don't have to be. The thing on the left usually indicates some sort of status, or sometimes these things just need to be grouped together, so you use tuples, right? So it's how you do multi-returns in Rust, the same way as Elixir. So on 22, reading this function, what this function says is, I'm going to make a function called add that this add has things in it that are going to use a lifetime of a, right? And this function has a lifetime of a, which means that a is an arbitrary term, right? It just means this function has a lifetime. What we're passing in is an env that is of type env that also has a lifetime of a. And what that means, sorry, these little quote a, single quote a, what we're saying is the env has to live as long as the function add, right? And the term over there in args, all of those terms also have to live as long as this function. And what this lets the Rust compiler do is say that the things that are passed in here all have to live as long as the function, and that means that they can't be deallocated, right, or taken off the stack while add is happening. That's all it means, right? It just means that they can't be, they have to live. We can't free the memory. We can't take those things off the stack while this function is happening, right? And that's something that the compiler uses to make sure that we're not screwing up our memory safety. For our use cases, honestly, for all of the use cases that I've used in Rust NIFs, I've never had to mess with lifetimes. These are straight up copy and paste, right? So you might not even have to know about them. On 23, what we're doing there is we are, we have this thing called try. That thing is kind of it's going away in Rust. It's being replaced with a question mark. And it's basically us telling the compiler, try to do this, and if not, panic, right? And without having to handle all of the cases and ways in which it could panic, right? And give us a meaningful error message as well. So when this panics, on the Elixir side, it's going to say argument error, but it's going to come with a message that says like panic. You tried to like decode an I64, but you didn't give us an I64. You gave us some other type, right? And then the same thing happens for num2. And then on 26, I read this as the result OK gives us a tuple that is OK and a sum, and code that into the end, right? So this is all it takes to write a NIF in Rustler, right? This is the simplest case. That is about the simplest they can get, right? And you can see I said I would mention this, on 26, we have atoms colon OK, and we're calling it like a function. We define that on line 9, right, inside of our atoms module. So similar to Luke's define these at compile time atoms and put them in the table. We don't have to worry about the table so much. This Rustler atoms macro takes care of that for us. So they just appear as function calls inside of this atoms module. Okay, so Luke, let's go to the next project. I'm going to show you guys how to use a thing called a resource, right? So you can pass things in to Rustland and make it do things to your data, right? Add your numbers together. Sorry, go back to the README. Sorry, go to the README again. Yep. Oh no, the sorry, the resource NIF, the README at the, yeah, the one on the left. There you go. Beautiful. Sorry. So you can pass things into Rustland and make it do addition on your numbers, right? But sometimes you want to pass back structures from Rustland that are basically references, right? So, and that's what a resource is. So, my use case for this, the way I came across this was I was building a neural network library in Rust and Elixir that was using matrices that were in native Rust, and you don't want to have to pass a list of floats into Rust and then pass a list of floats back, because that's no better than copying, right? So what I figured out was Rustler lets you very easily encode a resource, have it be memory safe, and have it stay in native land until you might need it, right? So the setup for this one ends up being, if you do go through the simple Rust NIF project and you get it to the point where you can add, you can go along with this. So in this folder for librs, right, we add a struct called the struct, right? So yeah, you can go to this, yeah. Oh, this is no, wrong one. There you go. So the difference here is we add a struct called the struct, right? I didn't get creative here. It has a field, and I made it a string, right? And this is a string that's on the heap, and that means that we own this. That means that this struct owns that string. It's not a static string, and it's not a slice that has to be shared. I'm not sharing memory with anything. This struct encapsulates the pointer to that string, the reference to it. So another difference here is on 13, there's a function called onload, right? And onload takes two arguments. I have never used load info, so I don't know what it does. But the important thing for me here is that it passes env through, and then we called this resource struct init on the struct, and we passed it the env. And what this allows Rust and Erlang to do is to sort of coordinate on the memory layout that is required for the struct to be passed into the env, right? And what that means is, so the way it works is we're going to, actually, let's just go down in the code and it'll become pretty obvious. So sorry, one more thing. So the sum on load here is correct, right? Because that sum is a callback, right? It says there exists a callback called onload, and I want you to use that when we export our NIFs, right? The other one was wrong because it should have been none, because I don't have any structs to export. I have nothing going on with that function. And we added two more functions in here. I called it get the struct and get the data from the struct. Pretty straightforward. So right here, get the struct. What is going on here is a one arity function. The one thing that I try to get out is a string, right? And this is a string that is shared in memory. So basically, this string exists in the args, and the thing that I get out on 45 is a label, as a reference to what was in the args, right? Is what I'm pulling out, data. I make our struct, and I give it a string from that data, which is, this is a heap allocated string now on 47. And then on 49, the magic sort of happens, and we call this thing called resource arc, right? So resource arc is a type that is provided by, resource arc is a type that is provided by Rustler. And what it is it's a Rustler specific or atomically reference counted structure. And what it does for us is it lets us pass this resource out and even pass it between Elixir processes And as you share it between Elixir processes, the atomic reference count goes up. And as the atomic reference count goes down, as it reaches 0, this resource is deallocated if it was allocated at all, right? So that's the whole tree that it's associated with goes away. I don't know if does this make sense to you guys? I don't know if I'm going too fast or
I didn't bring it up, but a lot of the NIF functions I use in C, almost all of them have a caveat of like, if you call this function, you may not keep this value once your NIF returns. So
yeah,
there is ways to hold on to data, but it's like illegal to hold on to it for most of the NIF functions I was using in C. There's a few that allow it, but it's a lot more work than like one-line macros like it is here in Rust.
Yeah, it's pretty crazy. When I found it out, I was like, this is exactly what I wanted somehow, and I found it. So Sonny Scroggin helped me a ton in the very beginning with figuring. So Sonny Scroggin's written a bunch of NIFs, and I was asking him questions, and he's like, this is exactly what you want, and he pointed me onto this resource arc. So this is extremely useful because I don't know if you guys use ETS. This is not quite the same thing, right? So on the other end of this, it's not quite the same thing, but it's really close, right? ETS has sort of got its own global. There are ways to look up all of the ETS tables that are used in a runtime, right? There's nothing that exists like this, but you could build it if you had to, which is the really amazing part. Is you could build some sort of registry out here in Rustland, make sure it's started, and then it could keep track of all of these resources if you had to. So you can do some pretty advanced stuff with this resource idea. So what happens is, if you go back to the README real quick, sorry, we're going to navigate back and forth a few times here. If you go to the README for Rust resource NIF right there, and if you just scroll down here, it's in here. There you go. Go all the way to the bottom. Right, all the way to the bottom. I should have an example, hopefully. Yeah. So this is what this is the output of running this, right? So you get the struct. I pass in a string. It gives me a reference. I put the reference into a variable because I forgot to do that on line 2. And then I say get the data from the struct ref, and it gives me back JSON, right? So what I've shown here is I pass this in. I pass in the string JSON. It gets put into a struct in Rust. I get a reference back to it. If I wanted to, I could mutate that thing, right? So we added mutation to the language just now with this NIF, right? If I wanted to, I could start changing JSON. All I would have to do is make sure that I expose the NIF and made sure that the struct could be mutated. Give it a method to mutate it, right? That type of thing. All right, so if you go back to the source code. Sorry, Luke. Told you we're going to be clicking around a bunch. Beautiful. Well done with the back button. All right, so yeah, so the last part of this is on 53, get the data from the struct, right? I expect one argument. I get the struct. I called it the struct, and it's of type resource arc, the struct. And it's interesting because when something is a resource arc, it ends up acting exactly in Rust. Rust has some real magic stuff going on, but it acts as if it were the actual data structure, even though it's actually the resource arc, right? So what I do there is I take the struct, I take the field out of it, and I clone the string because I don't really want to. I clone it because I'm used to using Rust, and I do not want Rust to ever complain that I'm doing something with the field of this instance of struct while struct is being used somewhere else, right? So I clone it. I don't know how else to put it. Like there's no way in Erlang that you could change the string's memory location, right? But Rust might not know that. So I'm really careful around my Rust code. So cloning is something you do. It's basically just saying like, I want a deep copy of this, which for a string, it's just, copy the length and pointer and then copy the heap. Yeah, so I encode that. Yeah.
I'm actually not sure what would happen if you try to keep it as an Erl NIF term between invocations, because in theory, pointers to Elixir strings to binaries are handles to, but they're still kind of encoding the pointers, which means it would be screwing what would happen if the garbage collector kicked in.
Yeah. So, yes, that would be really weird if it was like, here's the string and it pointed over to the Rust code and it's like, there's the string, and then it just started messing with it. Yeah. So I don't know. I didn't even try to pass field out here. I put .clone on it because it gives me the, so I've been doing Rust I've been doing Rust for 5 years or 4 years. Hold on. I've been doing Rust for 5 years, I think. Before I started even Elixir. Passing the struct.field without that clone gives me the willies for some reason. As in that thing, the struct owns field and it's on the heap, and if you tried to share it, I think it would start complaining because of ownership, actually. If maybe not because we're encoding it into env, but maybe, I'm not really sure. But I put it on there without even thinking, so I can't really tell you much more about why. But yeah, so using this, we've got two functional programs, two working programs, excuse me, that we built a simple Rust NIF, and we built a one that you can pass resources out of, right? So if you, yeah, good luck with this. I hope somebody gets to use this. I'm actually using Rust in a ton of side projects that I'm doing on my own. Like there are the Rust ecosystem is extremely rich with very interesting ways to manipulate data quicker than a lot of things in C or C++. And it ends up being really cool for me. I found a new project recently. It's called what's this thing called? Tantivy. It means to gallop. It's an Elasticsearch clone, and it's written in Rust and it's really fast. So I've been playing with that, and it basically lets me do full indexed searches of data, like right in Elixir, as if I had a database attached to it, but it's, you know, fast. So really cool stuff. Any questions on your end, Luke, for me?
Any questions on either side, Rust or C, or the interface in general?
If you ran into problems with like pushing a lot of data over.
I mean, you did the neural network. Did the neural network have a lot of data in it?
I didn't hear the question. Sorry.
Did you have any problems pushing a lot of data through to the NIF?
So my first pass was super naive, and I made a neural network that was going to train like 50,000 epochs. Did I have any problems? I noticed that the overhead was about 20 microseconds. I said something in my notes, about 22 to 20 microseconds per crossing of the NIF, the Erlang Rust boundary every single time, right? So regardless of the data type, regardless of the amount of data, pushing a lot of data, no, the overhead is extremely small, right? Like, I don't want to call it free, but pushing a ton of data was not a problem. Let's put it like that. My biggest problem was eating up the scheduler time in a slice that was like minutes long, and then being like because you know I'm just playing with this thing, and minutes later being like, why is my runtime breaking? Because I tried it 8 different times and that ate up on my threads. So there was only that, right? So the fix action for that was don't build a neural net in Rust, build the matrix in Rust, and build the neural net in build the piping in Elixir, and just pass references around, right? So I don't know if you guys get what I'm saying, but since I have a resource, I don't have to pull the data. It's as if I have a pointer in Elixir, and I just pass that along and say, there's your data. It's in that matrix that it's in this pointer, right? So, yeah. Did that answer questions at all?
Yep. from what I've read, the other like crossing the boundary stuff, so like Elixir, Rust WASM does the same thing where data doesn't cross the boundary. It's usually you pass handles back and forth to the data. And so like if it's JavaScript native, it stays JavaScript native, and you have like a handle because it's like the index of an array kept on the JavaScript side for that. And then the part of the WASM standard is that memory is linear. So like with that handle, it can reference the memory in the JavaScript memory space and get it that way. And the other way with Rust 2, where the WASM memory space is linear, so that you can just go back and forth with references and you don't actually copy the data over.
Right.
The reason why pushing data over is free is because, like I said, those aren't pointers to memory, so you're not converting the data types unless you're doing stuff like I was doing, where you're taking a Perl NIF term and turn it into an unsigned long. Like that is a data conversion. But if you were just getting the value out, then it's the same memory. That handle is the same handle of memory that the actual beam bytecode would use, so you're not copying the actual data. It's the same value.
Also, one of the things that I do when I'm building my data structures in Rust versus Elixir, I don't try to. So Luke showed an example where he put a struct in CLAN. I do not do that. And the reason I do not do that is I had a very painful time doing that before. So what I started doing hilariously, and it feels a little dirty because it feels like I'm going backward to like Erlang, but I started using tuples for it all. So it's like order-oriented structures. But what I found was I struggled with a lot less time maintaining a struct. And if I needed to change the underlying tuple, I would just change it at that layer of, the Elixir native module and the Rust lib module that defines how to turn that tuple into whatever data structure I need on either end. But that's just preference, right? I'm just saying like preference. Like I try not to put my structure into my Rust NIFs, because for me it ends up being a pain in the butt to maintain, right? Or maybe I'm using structs wrong and I'm like letting them leak too far into my abstractions. Maybe, I don't know.
The fact that I was only returning them made it easier, but even that you saw was like make sure the count is right, make sure the order was right. But all the C-level stuff is the same as you would in Elixir, but harder because it will always output a new map when you make a change, so it has to. But that's a lot harder in C to not mess up, because you're constantly like giving a pointer, but make sure that you didn't set the value first, it's just sitting there and it's initialized correctly. And also reading them out is painful because you're getting new NIFs back out. And so returning that worked, but I would say with the tuples, like what their platform text talk about how the new MySQL database driver is using records internally because it saves space. So like, if you are never showing the outside world your format, records may feel older and like not as Elixir-y, but it takes up less space. And so it can be, you could do tuples that are tagged, and that's just a record.
Right. What do you say? Anybody got any other questions?
Yeah.
So obviously, got 1.8. How active are they keeping alive?
How active is Rust maintenance right now?
That's a good question. Pretty up to date as far as I know. I haven't encountered a broken Rustler build ever. Yeah, 8 days ago they put some new macros in, and before that it was 17 days ago, and then a month ago. So pretty active.
Did they implement enif schedule NIF in Rustler? I remember seeing an issue where they couldn't figure out how to do it where it would still be safe, so they weren't going to do it.
I don't know actually. You're talking about where it breaks, where it makes it preemptible.
Yeah, like the thing I did for my more complicated example. Like I know there's debate about how you do that.
Actually, Luke, your example was the first time I've ever seen that, so I don't know. I was actually a little amazed when you were talking about it. I was like, Well, that would have solved that problem. Yeah, my solution for that was just don't use up large time slices, right? So I know, like, I know you're like, but you do matrix math, but like matrix math is extremely fast, right? So even on a matrix that's, sorry, 2D matrix math is really fast, not matrix math. Like 2D matrix math is really fast. Even if you have a matrix that's 1,000 by 1,000, right? It's still going to happen fast enough that you won't upset the scheduler if you do one layer at a time. So my solution to not incurring that time over time. My solution for not messing with the scheduler was to split the layers up into it to make it so that only one matrix operation happened at a time, basically. And that's
actually like the paragraph right above the part about how to use NIF scheduler is like, you could just have the code return and have Erlang call it again. Like, you don't have to do the scheduling from the NIF side. It is purely an like ergonomics argument, or if like you have too many, if you have too much data floating that's like only makes sense in C, you can do it again. But the weird part about that is you always need something that's an Erl NIF term as like a handle to get that data back, because you always have to reinvoke at a NIF level. You can't just do a C level callback for the rescheduling. So it sometimes feels weird to restart because you have to encode and then decode the NIF terms just to restart your work.
Yeah, that's cool. I'll have to I will ask about that in Rustler, see if the scheduler what's going on with it, but I don't know. I don't know anything about it. Sorry, guys.
So I'll quick show what the makefile looks like since I didn't have time to cover that in a slide. Let's see. Full screen. So this big long line is calling Erl to evaluate a string to tell us where it is. You think, oh, there's an earlier thing, there's like a package config. No, everyone does this. You call Erl with an eval to ask it, where are you located? I do the same thing in IntelliJ Elixir. I've never seen a simpler way that like works on all ways people install Erlang. So you just have to ask it where it is. And you have to tell it to stop, and you have to make sure that the shell doesn't turn on. It's a very long string. Important caveats, you have to make sure that the code's position independent because it's a shared library. There's special flags for Mac because the kernel is called Darwin. So this is also from the bcrypt library. So you have to say that's going to be dynamic lib. Yeah, that's the important parts about doing the actual makefile. Like I said, it's in this repo, and it's also just look in bcrypt. You know, it has the stuff in its makefile, and you can just copy it out. And they also have bcrypt is compilable on Windows, so it also shows you any weirdness you have to do to make it work on Windows. What else we got?
So one question for you, at least you're trying to find the path to the Erlang binary.
Well, it's like where the technically it's the path so that you can have erlif.h. Because that's what you care about. Yeah, it's calculating the include path.
Just from a Linux perspective, like which and basic.
Yeah, that's not what it. Yeah, that's not what I'm saying. Where Erlang is, it's like where the install is, because that's usually where the headers are. I'm assuming this works if you're on a system like Ubuntu where the dev packages are separate, but I'm not sure. Because I would think they'd have to make Ubuntu and like the dev package Linuxes work. So I'm assuming this always works since it isn't bcrypt, but any other questions?
Sometimes this is a statement. One thing I always thought was kind of interesting was there's a project up on GitHub right now. A guy's working through implementing Rust.
Yeah.
But he's not close to being finished. But I just thought that would be kind of an interesting take on. It's already, pretty rock solid, but start adding all those protections and get that all on top of it. It's very interesting.
What?
So there are resources in the C stuff, but you have to do a lot. It's not one line. It's a bunch. It's a bunch of arguments compared to how simpler it was in Rust. Like, it is not simple. You also, like, you have to do everything through the beams. Like, where else is it? There's like stuff to do, the IOVEC, so like all the stuff about like IOVEC writes, where like IO lists are faster write, NIFs can do those. So you're not stuck doing slow writes at least. And that's what all the IOVEC is about. And this stuff, IOQs, but like there's even wrappers for creating mutexes. So like you don't access pthreads directly. You have to go through all these wrappers. I'm not sure what happens if you like. So I'm trying to think what library it is. It's there's a Q library. Oh, it has a Z in the name. But like the way it works is it actually makes a thread to be the listener. So like instead of doing RabbitMQ, like you put the Q listeners in your thing, and that creates a thread, which means those threads are monitored by Beam. So if you use these, unfortunately, all your C libraries have to know to call these, because otherwise you're going to have like all these resources that C makes that PS is going to say you own, but like Observer can't see them. You'd have no observability into it. So unfortunately,
do this, Observer is going to show those.
Right. Okay. Like when you make a thread, you have to actually give it a name. So like here, you can name your threads. Or you can at least get the name of the threads. And those names are, I think they're the same names. So like when I got the segfaults, the threads, at least on Mac OS, are named. So like it said scheduler 1, scheduler 2, scheduler 3. So they at least will show up. And so if you were doing something that was thread heavy and a NIF, you at least would have better GDB and LLDB support when it does mess up if you use these calls. Yeah, there's also conditions, which is stuff for coordinating threads.
When I was building the neural net stuff, excuse me, just one second. I'm trying to think about this. The Rust compiler would not let me do things without wrapping stuff in a mutex. Basically, the matrix math, the matrix struct, it recognized as, I believe it recognized it as heap allocated, and it's like you need to wrap this in a mutex because env is a possible sharing environment, right? Like env is multi-threaded, so and we can't tell you how, so you must, You must put a mutex around this. So all of my stuff ended up being mutex wrapped in that project.
I will say from doing pthread and mutex in C, which, you know, even if that's a pthread wrapper, it's still going to act like the pthread interface, is that mutexes in Rust are sort of like open resource in Java, or like the like open or resource block in Python, where you're not allowed to have you're not allowed to own look at the thing inside the mutex that the mutex owns without having the mutex owned. So like the mutex is not separate from the data that is being protected by the mutex in Rust, which makes it much safer to do, even if you go down the level of using mutexes. Any other questions?
You have a list, like an awesome list of NIFs somewhere, or
Not that I'm
go to GitHub and looking for, you know, Erlang, NIF, Rust.
Yeah, I mean, the only way I can think of that I know we all use it is bcrypt. I would say the sec phash one that like implements the hashing algorithm that Ethereum uses is garbage because it breaks half the time. So don't look at that one, or look at that one to be like what not to do.
I tried to get Couchbase. I don't know if you guys have ever heard of Couchbase. It's a database, enterprise database. It was a nightmare. I tried to get, there's an Erlang library that uses a NIF called libcouchbase, and it would crash seemingly randomly. Crash me out of the VM. Like I tried to use it for like 8 days in a row, and then the eighth day I was like, forget this thing. I'm not using this. Like I'll write my own driver for this thing if I have to. But yeah, I don't know of any other NIFs that everybody uses other than the bcrypt NIF, because it's so necessary, right?
Editing, or try like your Raspberry Pi or a Beagle. In other words, if you compile ARM.
I don't see why not, because it won't, like, as long as the C library was, the interfaces, like the headers, keep the types consistent. No, I would say the big thing would be is if it turns out like the return type from enif, schedule NIF, where like the return type is undocumented and it existed but only in a header that you don't have as a NIF, that is only there when you have from the beam, you'd have to be careful that those values were consistent across ARM and x86, and that you might have to worry about endianness.
Right.
I mean, I kind of consider that almost like a bug.
Sorry, is this a question about sharing types between?
No, if using NIFs for embedded devices.
Connor Rigby works for FarmBot. He's been playing with Rustler for a few weeks now. You might contact him and ask him about targeting different architectures. And so he had a problem that he had a weird problem where he wanted to share a C structure into Rust land, and I was like, dude, I don't want to even get into like how the memory is laid out. Like in C, it's like, how's the memory laid out? Like however you want. In Rust, it's not like that. So I don't know how far he got, but my advice to him was, I don't want to talk about it. Basically, he was asking about it. I was like, Connor, I don't know enough about computers for this. So yeah, sorry.
Any requests or ideas? Oh, sorry, we don't need a topic for next month. Next month will be anyone that needs to rehearse for Lone Star Elixir can do that. So I will do it, and if anyone else is speaking, they can do it too. Otherwise, we are always looking for topic ideas because we'll need one for March, of course, and every other month this year. So if you want to talk, we also don't need one topic. We can do this sort of thing where we split. You can also invite your friends from other places, like I do, to cover for you. But yeah, otherwise, same as this month, I will send out an email at the end of the month going, hey, what do you want covered?
So we talked about your own 1.8 changes with the time zone.
Oh.
You can actually time zone without a third-party package.
Yeah, I actually haven't tried that out yet. I don't.
I'm just curious. I mean, it seems, we've actually had difficulty that which TC package or TC day or whatever, we've had difficulty with it, like not being able to go grab the file or.
Yeah, there was a weird thing where like it couldn't fetch under certain environment conditions because like it wasn't allowed to write the data back or something. I remember that was a problem a while ago.
It's very, very weird, but
yeah.
For the 1.8 release, like they've included that in now, so it's part of like their time zone.
Yeah. Yes. Time zone 0 is a nightmare.
Oh yeah. I once had an argument with somebody about, well, it's not a time zone. It's the lack of.
I know. It's always fun when you realize that at first you're like, this, we'll just use UTC for everything, and then you realize that the way people set their appointments, they actually care to keep it in the time zone they set it in. And then you're like, how do we fix the data?
Right. So in essence, like we tackled this problem for like scheduling and things by saving the time zone along with UTC.
Yeah. My understanding is that that is one of the few reasons to still keep the timex time types, is that their time type will preserve the original time zone as part of like the data that's pushed to the column or kept in a separate column, so that if you really have like a multi-time zone like appointment or scheduling system, that it is better than even the more modern like direct time support in Acto.
I guess another question would be, so Chris Report is still
Live view?
Have you heard anything about that?
Well, yes, he does talk about it in Slack some.
So there's a lot of people saying, when is it going to happen?
It will be out.
I don't want to be that ass. I don't want to be that ass. Has anybody heard anything about what he's doing?
We got a demo like 4 weeks ago. It was cool, but it's still not ready yet. So I don't know.
Part of the gating was 1.8 in, so EEX ships as part of Elixir. Part of EEX, part of live, so the way a lot of stuff works, the way Chris describes it is like he comes up with a cool idea, and then Jose comes behind and like ups the performance, uses like Erlang better. And so part of that was Jose figured out how to have live EEX, where like it computes what was the diff, and so it can spit out the diff from a normal EX template. They made a separate sigil, but that shipped with 1.8. So LiveView seems to be predicated on 1.8. So maybe it's closer to being releasable now, with the caveat that you have to use 1.8 to make it work well, or fast anyway.
One of those waiting motivated reps sort of things.
Yeah, we've debated on certain clients where like they started to use more and more JavaScript, but they didn't like all they really wanted was live updates or functional. Like we could live view this and it would be easier because we don't need a dashboard. We don't need a full SPA. We just need to like add a div at the top when new data pulses in.
I too suffer from these exact same problems in nearly all of my personal projects. Like, I would like to build a front end, but I really don't want to have to build out a huge API and all of the JavaScript and basically like I don't want to do a full SPA. I don't want to do a front end app. I just want a few components to like update themselves. But that's never how it works right now. So it's always like, I feel like it's always all or nothing, right? Because I'll get to this point where I'm like, I've got 10 components now, and then it's just like, well, now they need to share state, and now, or now I really wish 2 of these would share state, and then at that moment I'm like, it's time for an SPA, right? And that's happened to me probably 5 or 6 times in the last 2 years. So I don't know.
I think we haven't had to worry that much about the front end. Mine is mostly how can I trick the database to be faster?
Okay.
No. Mine is like, how do I do the fastest amount of updates with doing the minimum number of writes so that Postgres doesn't have to vacuum all the time while doing upserts? I've slowly become a DBA.
You could write a book called Accidental DBA.
I mean, that's pretty much what my talk's going to be at Lone Star.
Oh my God, I'm a DBA, shoot me.
I haven't gone so far of like screw y'all, you're not touching the database. You have to call my SQL function, my PGPL SQL functions. You can't do actual inserts anymore, but it's gotten close.
It's better than the assets of the project.
Hilariously, just so you guys know, this is back on topic for the talk, but I've used Rust NIFs to hook into RocksDB. I've used Rust NIFs to write to this Tantivy database, and it makes me stop. Sorry, not that I don't have to worry about performance, but I don't have to worry about network I/O, right? Like that completely out the window with this solution. So to put it differently, I've had a client in Dockyard for the past 9 months that were really worried about insert performance. And we've been trying to use Postgres, and I suspect that in the next few months it will move away from Postgres because we can't get the throughput we need from it, even with batched inserts, even with a ton of stuff. So I think they're going to be going with something like just dump this directly to disk, right? Something like that, where it's just like we need stuff to be faster. We're feeling the pain of not getting the throughput on Postgres.
So with that, we can call it for the night. Thanks, Jason.
Ciao.
Thank you all. Appreciate it. Talk to you soon.